In this video, we're going to talk about how to do a hypothesis test using Minitab. So we have another thing to identify here. We already talked about how to identify null and alternative hypotheses. The problem is also going to give us a level of significance. And we use this symbol alpha. This is the Greek letter alpha, lowercase. Kind of looks like a cross between an A and a fish. That is the level of significance that we're going to use. And we need to relate the alpha level given in the problem to the confidence level in Minitab. And the relationship is given by this formula. Confidence level equals 1 minus alpha. So if alpha in the problem is 10% or 0.10, we would use 90% confidence. An alpha level of 5% would be 95% confidence, and an alpha level of 1% would be 99% confidence. So we're going to use Minitab to calculate something called a p-value, and we compare the p-value that Minitab gives us to the alpha in the problem. And this tells us if we reject or fail to reject the null hypothesis. We reject the null hypothesis if the p-value is less than or equal to alpha. We fail to reject the null hypothesis if the p-value is greater than alpha. Note that we never accept the null hypothesis. Our only two options are to reject the null hypothesis and fail to reject the null hypothesis. If the null hypothesis is rejected, that means that there is sufficient evidence to support our claim, or the sample data is supporting the alternative hypothesis. If the null hypothesis is not rejected, that means we do not have enough evidence to support our claim. And that means that the sample data is supporting the null hypothesis. It's not proving the null hypothesis or the alternative hypothesis either way. All we can do is say that the evidence supports either the alternative or the null hypothesis. So there are 6 steps in putting together a hypothesis test. First, we have our claim, and then we write our null and alternative hypotheses. Step 3 is to determine the significance level that we want to use. The problem is going to give it to us, and figure out what our p-value needs to be in order to reject or fail to reject the null hypothesis. So this gives us our rejection rule. Step 4 is to use Minitab to do our calculation. And we're going to be using the same 3 tests that we saw in calculating confidence intervals. 1p, 1z, and 1t. We use p for proportion. We use z if sigma is known or the problem is giving us population standard deviation. We use t if sigma is not known or we're given sample standard deviation. And Minitab will calculate the p-value for us. So after we get the p-value, we can decide whether we're going to reject the null hypothesis or fail to reject the null hypothesis, and then we can make a conclusion in non-technical terms. So, for example, a consumer advocate claims a manufacturer of potato chips is underfilling the bags. The bag states that the contents weigh 12.5 ounces. Assume that the population standard deviation is known to be 0.12 ounces. Now this is population, so sigma, so that tells me that I'm using 1z. Suppose the consumer advocate gathers evidence by obtaining a simple random sample of 36 bags of chips, weighs the contents, and obtains a sample mean of 12.5 ounces. Using the p-value approach, test the consumer's claim at the alpha equals 0.1 level of significance. So in Minitab, we're going to go to the same place where we went to for calculating confidence intervals. So you can go to one sample and select, in this case we're using z because we're given a population standard deviation. Sample standard deviation, I would select t, and if it was a proportion problem, I would select proportion. And we've seen this menu before. First, I need to change sample data in a column to summarize data. And then I'm going to enter my sample size and sample mean and the known standard deviation for my problem. So my sample size here was 36, my sample mean was 12.45, and my standard deviation was 0.12. Now this time I'm going to check the box that says perform hypothesis test. And when I check that box, I get a box where I can put in the hypothesized mean. So this is the mean that I'm hypothesizing, that the value is greater than, less than, or not equal to. And we didn't write our hypotheses here, but let's go back and do that now. So my null hypothesis is that the mean bag of chips is equal to 12.5 ounces. And my alternative hypothesis, well, they think that they are underfilling the bags. So their hypothesis is that the mean is less than 12.5. Or in other words, the bags weigh less than 12.5 ounces. So let's bring this back up here. My hypothesized mean would be 12.5. Now I need to go over to options. Now I do need to change this alternative hypothesis box, and I need to change it to match my alternative hypothesis. So my alternative hypothesis was that the mean is less than 12.5. So I'm going to choose that middle box. Mean is less than hypothesis value. And then I'm going to change my confidence level. So in the problem, it said alpha equals 0.10. So my confidence level is going to be 90. Then I click OK. And here's what comes up. Now I should check here that all my information is correct. N is the number in the sample. I have the sample mean and known standard deviation of 0.12. Here's my null hypothesis and my alternative hypothesis. Those match what I wrote earlier. Notice that they're using H1 for alternative hypothesis. And they're giving you two values here in this table, Z value and P value. Now on the homework, you're going to see that my stat lab is going to ask you to put in the Z value. So you would just type that in, negative 2.50. And then they're probably going to ask you to put in the P value as well. So you would put in both numbers just directly into the box, rounding if necessary, depending on how many places. So this p-value that I'm given is 0.0062. And that's what I use to draw my conclusion. I don't use the z-value, but like I said, you probably will need to put it in the homework problems. So p-value 0.0062. So now I'm comparing that to my alpha of 0.10. And what this tells me, my p-value is less than alpha. So if p-value is less than alpha, then that means that I can reject the null hypothesis. So that gives me evidence to support my alternative hypothesis. In other words, there is evidence that the bags are being underfilled.